Find the volume of the solid whose base of S is a circular disk with radius r. The parallel cross-sections perpendicular to the base are squares. First, we will draw the base, which is a circular disk, and we then build the solid using the cross-sections that are perpendicular to the base, and these cross-sections are squares. Oftentimes, with a circle, we position the circle so that the origin is at the center of the circle. The equation of the circle with radius r is x squared plus y squared equals r squared. So the x-intercept is negative r and r. The y-intercept is negative r and r. Now, the volume of the solids is the sum of the volumes of each of the cross sections, where each of the representative cross sections has a volume by the area times the thickness. But the area of the square is S squares, where S is the side of the square, which is the vertical distance in the diagram. Oftentimes on the graph with the cross section, we label the intersection of the cross section and the graph at the point x, y. The horizontal distance from the origin to the cross section is x, and the vertical distance from the origin to the point is y. So we can see that the length of the square, the side of the square, is twice the y distance. Thus S equals 2y. But since the volume is in terms of x, we want to express y in terms of x. The relationship between y and x and the radius r is x squared plus y squared equals r squared, which is the equation of the circle, or we can use the right triangle and apply the Pythagorean theorem. We will see that x squared plus y squared is still r squared. Since the volume is s squared times delta x, the volume is therefore 2y squared times delta x. But this is 4y squared delta x. In terms of x, y squared is r squared minus x squared, where we isolated y squared from the equation x squared plus y squared equals r squared. This is only the volume of one representative slice. The volume of the entire solid is approximately the sum of the volume of these representative slices. As I go from 1 to n, each of the cross sections has a volume of 4 r squared minus xi squared times delta x, where r is fixed and x vary depending on where we slice or where we obtain the cross sections. As n go to infinity, we would obtain the exact volume in the form of the integral of 4 times r squared minus x squared. The delta x is now dx. The limit of integration is where we added all of the slices or all of the cross sections. We added all of the cross section from x equals negative r to x equals r. So the lower limit of integration is minus r, and the upper limit of integration is r. Note that in the Riemann sum, it is only the approximate volume. But when we rewrite the Riemann sum in the form of the definite integral, we would obtain the exact volume.